In this video, we're going to look at how we can determine whether or not a square matrix is invertible and how to find the inverse if it is in fact invertible. So if we're given some matrix A, we can find its inverse in the following fashion. So we take 1 divided by A times D minus B times C. Remember, this is just the determinant of A, times this matrix. So to get this matrix, basically what you do is you switch the positions of A and D. So you just switch A and D, and then you change the signs of your two elements on the other diagonal of this matrix. And again, this happens if the determinant of your original matrix is not 0. If the determinant of your original matrix is 0, what that tells us is that the matrix is not invertible. So not every square matrix has an inverse, and we can tell if it does or not based on its determinant. If its determinant is 0, it is not invertible. Otherwise, we can find its inverse. So let's take a look at how we can do that. So we want to find the inverse of this matrix if it exists. So first, let's find the determinant of A. So the determinant of A is -1 times -2 minus 8 times 0. So that's going to be 2 minus 0, which is 2. So the determinant of A is 2, which means it is invertible. And we can find the inverse of this matrix. So A inverse equals, so it's 1 divided by the determinant of A, so 1 divided by 2, times the matrix where we switch these two values, right? So switch along that first diagonal, so -2 and -1. And then we switch the signs of these. So this should be -8 and 0. And now we just perform this scalar multiplication. So distribute your 1/2 in to all of your elements. And we should get -1. 1/2 times 0 is just 0. -8 times 1/2 is -4. And then -1 times 1/2 is -1/2. And you can always verify whether or not this is the actual inverse by just doing your matrix multiplication. And you should result in a square in your identity matrix of 2 by 2 identity matrix. So this should be the inverse of A.